Please be seated. I'm Joe Helbley. I'm the Dean of the Thayer School of Engineering, and it's my pleasure to welcome you to the Thayer School's 2015 Investiture ceremony. At commencement exercises tomorrow, the Thayer School will award 153 degrees. This includes 82 Bachelor of Engineering degrees, 21 of them to students who have earned both the Bachelor of Arts and the Bachelor of Engineering degrees simultaneously in 4 years, 51 Master of Engineering Management degrees, 8 Master of Science degrees, and 12 doctorate degrees. In addition, Dartmouth will recognize 77 engineering sciences majors with AB degrees at tomorrow's ceremony. I'd like to begin today by introducing you to our platform group and our faculty and student marshals. On my immediate right, Dr. Stephen Chu, the William R. Kennan Jr. Professor of Physics and Professor of Molecular and Cellular Physiology in the Medical School at Stanford University. Dr. Chu is our speaker today, and I will introduce him more formally in just a few moments. Carolyn M. Dever, Provost and Professor of English. At her immediate right, Dr. Ian Baker, Senior Associate Dean for Academic Affairs and Sherman Fairchild Professor of Engineering. Next to Professor Baker, Brian W. Pogue, Professor of Engineering and Director of our MS and PhD programs. Benoit Cushman-Razan, Professor of Engineering and Interim Director of the MEM program. Edward March, Adjunct Professor of Engineering and Interim Co-Director of the MEM program. And B. Stuart Tremblay, Associate Professor of Engineering and representing the BE program this morning. To my left, starting closest to me, we have Mr. Terrence McGuire, Thayer Class of 1982, co-founder and managing general partner of Polaris Venture Partners, and the chair of the Thayer School Board of Overseers. Next to Mr. McGuire, Mr. Chris McConnell, Dartmouth Class of 1975, President, Adondo Corporation, and Thayer School Overseer. Mr. Richard W. Couch, Dartmouth Class of 1964, Thayer Class of 1965, and founder and chief executive officer of Hypertherm Incorporated, and Thayer School Overseer. Christopher K. Hu, Dartmouth Class of 1969, Thayer Class of 1970, counsel, Black Rome LLP, and Thayer School Overseer. Mr. Peter Fahey, Dartmouth Class of 1968, Thayer Class of 1969 and 1970, former partner at Goldman Sachs, Thayer School Overseer, and former member of the Dartmouth Board of Trustees. Mr. John Replogle, Dartmouth Class of 1988, Chief Executive Officer and President of Seventh Generation, Dartmouth Trustee and Trustee Representative to the Thayer School Board of Overseers. Ms. Peggy Epstein Tanner, Dartmouth Class of 1979, Chair of the Board of Seeds of Peace, and Dartmouth Trustee. Ms. Sherry Oberg, Dartmouth Class of 1982, Tuck Class of 1986, former President and CEO of AccuSphere Incorporated, and Dartmouth Trustee. And Mr. Mitchell Kurtz, Dartmouth Class of 1973, and Academic Dean, Director of College Counseling, and Chair of the Mathematics Department of the Bronx Center for Science and Mathematics, and Dartmouth Trustee. I'd also like to recognize our faculty marshal, Mark Borsuk, Associate Professor of Engineering, and our two student marshals, Megan Dagler, Dartmouth Class of 2014, Thayer BE 2015, and Mr. Drew Matter, Thayer MEM Class of 2015. It's my pleasure to welcome this distinguished group here today and to welcome each of you, parents, husbands, wives, brothers, sisters, and other family and friends who've played such a critical role in helping our graduates reach this milestone today. To start our ceremony, it's my pleasure and privilege to welcome our Provost, Carolyn Dever, to the podium. As Provost, Carolyn is Dartmouth's Chief Academic Officer. She came to Dartmouth 1 year ago from Vanderbilt University, where she served as the Dean of the College of Arts and Sciences. Carolyn is an English professor with research focused on 19th century British literature and culture. She earned an A.B. in English and American Literature from Boston College and an M.A. and Ph.D. in English and American Literature from Harvard University. Carolyn?
Thank you, Dean Helbley. I'm realizing this is a tall podium and I'm a short provost. So if I can't see over and make eye contact with the faculty, I apologize for that. Good morning, everyone. It's my pleasure to be here with you to celebrate this year's Thayer School graduates. As you might imagine, I've attended quite a few graduations and investiture ceremonies, but this ceremony will be my very first as Dartmouth Provost. Now, much like a parent, I can't claim to have favorites, but let's just say that I have a great affinity for the work of Thayer's faculty, staff, and its students. So today's ceremony is especially meaningful to me. It's customary to offer some words of wisdom to the graduates, but it occurred to me that this is a rare moment to share how you inspire me. I spend a lot of time thinking about how to educate students for a lifetime of leadership, how to provide knowledge and experiences that will enable our graduates to continue learning long after their time at Dartmouth ends, and hopefully how to help graduates be prepared to take action for the benefit of humanity. Thayer has an inherent advantage here. The very nature of engineering requires a deep knowledge of math and natural science, two broad and technical disciplines in their own right, combined with the ability to analyze and synthesize data, and a nuanced understanding of how to apply these practical skills within the context of an ever-changing human experience. That's a tall order, but we can't begin to provide the solutions the world needs today without people like you who possess this array of talents and knowledge. As technology makes it easier for us to connect with diverse cultures, environments, and people, we're increasingly finding that there are no more simple fixes, and there likely never were. Across the globe, none of our actions can exist within a vacuum. Every choice we make will have an impact on others, sometimes for the better, and sometimes with unexpected consequences. At Thayer and at Dartmouth, you've not only been studying this as a theoretical concept, you've been living it. You've acquired the sort of experiential hands-on learning that many professionals don't have access to until years after graduation. The diverse, intentional experiences you've undertaken will be key differentiators in your lives. Through these experiences, you've gained not only the academic foundation so clearly needed for your scientific work, but you've also learned to be nimble, resilient, creative, reflective, and collaborative. You have spent time navigating how the perfect solution won't work when it conflicts with cultural values and norms. You've worked through these challenges in real time and with real consequences, often bringing about systemic change that will impact communities for generations to come. Better than most, you understand how hard it is to create meaningful change, and you have embraced this challenge. On any scale and by any measure, your work is inspirational and powerful. Anatole France, the author, wrote that to accomplish great things, we must not only act, but also dream, not only plan, but also believe. Graduates, you have the intellect and skills needed to plan, and you have already demonstrated your willingness to take incredible action. As you go forward, believe in yourself and your ability to make a difference. Your education has prepared you well for the opportunities ahead. Know that you have the resources and wherewithal to risk failure and ultimately succeed. And by all means, keep dreaming. Given what you've already accomplished, I can't wait to see what lies ahead. Congratulations.
Thank you, Carolyn. It is now time for us to recognize the award recipients from the graduating class of 2015 and also members of our faculty and staff for special recognition earned throughout this past academic year. So let me start with instructions to our recipients. When your name is called, please come to the stage using the stairs on my right. That would be on your left. And remain on the stage while I finish reading the citation accompanying your award. After receiving the award, please turn, face the audience, pause for a photo, walk over so that I may congratulate you, and exit from the opposite side of the stage. As talented engineers who have spent many years with us, I am quite confident that you can execute according to those instructions. The first award that we would recognize this morning is the Dartmouth Society of Engineers Prize. The Dartmouth Society of Engineers Prize is awarded annually for outstanding performance in an engineering project by a Bachelor of Engineering student or student team. This year's prize goes to Megan Dagler, William Jewett, James Capel, Karina Packer, and Alex Rowe for their BE capstone project, where they use sound biomechanics and motion analysis to develop the working specifications for a bike. This is the point at which you should be rising and coming to the stage. Stay there. They developed an adjustable prototype bicycle to challenge and validate their assumptions and built a production model bicycle from scratch. Their final product, the Libby Leaner, is not only technically sound and well-designed, but in many ways a work of art and one that is in fact market-ready. Congratulations to this team of students. The Charles F. and Ruth D. Goodrich Prize is awarded annually in recognition of outstanding achievement with special emphasis on academic achievement. This year's prize goes to PhD candidate Adam Glazer. Adam? Adam not only achieved a high pass in 10 of his 11 courses, but he contributed to 17 published papers, including 7 as first author, and developed a way to do tomography of radiation beams with Cherenkov light imaging, which led to 3 patent filings in addition to the 17 papers, and the establishment of a startup company to develop the technology. So please turn so that we may take your photograph with the award. The Thayer School of Engineering Corporate Collaboration Council Engineering Management Prize is awarded for outstanding performance in the MEM internship course and project by an MEM degree candidate. This year's prize goes to Darshil Gandhi. Darshil? For his project conducted in conjunction with Borealis Ventures, Darshil created a new data-driven tool to speed up by 29% the time needed to reach an investment decision. This new tool resulted subsequently in a swift decision by Borealis Ventures. We need to extend a job offer to this candidate. Congratulations, Darshil. This year, the Olmsted Engineering Science Prize and the Thayer School Faculty Award for Excellence are being awarded together. The Richard W. Olmsted 1932, Thayer 1933 Prize is awarded annually to a Dartmouth senior majoring in engineering sciences in the AB degree program to recognize outstanding performance in the major. The Thayer School Faculty Award for Academic Excellence recognizes the student who has obtained the highest academic record in coursework required for the Bachelor of Engineering degree. I am pleased to announce that this year both awards go to Sarah Hammer. Sarah? Sarah, who many of us know as the student diligently working away in the Great Hall on problem sets at any hour of the day and night, achieved a 4.0 GPA in the engineering sciences major modified with chemistry. And at the same time, she also earned a 3.98 GPA in her Bachelor of Engineering coursework. Extraordinary performance. Congratulations, Sarah. The Thayer School Dean Service Award recognizes the student or students who have made exceptional contributions to Thayer School, Dartmouth College, or the broader world. The recipient is selected from nominations made by members of the Thayer School community, faculty, staff, and students alike. This year's award goes to MS degree candidate Christian Ortiz. Christian? As one of Christian's nominators says, anyone you talk to at Thayer has interacted with Christian in some way. He has helped students in Engines 21, the Introduction to Engineering Project Design course, with their projects, work with Professor Vicki May in Thayer's Design It, Build It summer camp for high school students. He gives tours of Thayer to prospective students, has assisted with first-year students' information expo, has spoken at orientation events. He served on the Thayer Student Philanthropy Council, has helped Thayer's Development Office with alumni tours and events, helped with this year's Chaired Challenge, created many gifts for Thayer visitors and guests in the machine shop, and he has represented the Biomimetic Design Lab at Thayer School's open house. Many of you have seen him in the basement, making cotton candy as a demonstration of the properties of material science that's particularly appealing to a certain age demographic that comes to visit our open house. Christian is known at Thayer School as someone who is always willing to pitch in, always able to get things done, and in doing so makes Thayer School a much better place. Congratulations, Christian. The John C. Woodhouse Engineering Design Prize is awarded annually to a Thayer student who has shown innovation and ingenuity in developing inexpensive yet effective experimental research equipment. This year's prize goes to BE candidates Jonathan Brink-Roby, Eric Clemenson, Malia Kawamura, Matthew Keller, and Eric Miller for their BE Capstone Engineering Design Project, testing and validated a 10-horsepower Walvastart propulsion system. Walvastart is a marine propulsion system that aims to achieve efficiency by mimicking the motion of a whale's tail. The team built a prototype, conducted extensive testing to validate the efficiency of the propulsion design system in just a two-term engineering design course project. Congratulations to you all. The John C. Woodhouse Environmental Engineering Prize is awarded annually to a Thayer School student or team who in a given academic year have done the best work in the field of environmental study or research. This year's prize also goes to a student team: Christopher Brown, Sarah Hammer, James Kennedy, Timothy Sirks, and George Wanjiru for their BE Capstone project, designing a system for removing contaminants from agricultural runoff from Shelburne Farm into Lake Champlain. The team set a primary goal of removing at least half of the phosphorus in the runoff from the farm's compost piles. As part of their project, they not only designed and provided guidelines for a 55-gallon pilot-scale system, but they recommended that a future Engines 8990 group be tasked with completing laboratory testing and constructing a reactor ready for full deployment in 2016. Congratulations to the team. The Caroline Henderson Prize is awarded annually to the outstanding MEM degree candidate in recognition of academic achievement and service. This year's prize goes to Heather Cluck. Heather? With a record of high passes and passes equivalent to a 3.85 GPA, Heather earned the highest GPA in the MEM class of 2015. In addition, she is an outstanding design engineer, with her group having won the design class prize very recently in Engines 146 Computer-Aided Mechanical Engineering Design. Her work on a low-cost water purification system for the developing world also earned praise and recognition from Engineering 178 Technology Assessment. Congratulations, Heather. The Special Faculty Award for Engineering and Service to Humanity is provided annually to recognize a student or a team of students in any degree program for exemplary achievement focused on the application of engineering in service to society in the true spirit of the Thayer School of Engineering. This year's award goes to a team of students, BE candidates Scott Hansen, Stephen Jenkins, Jamie Potter, and Julia Zakorski, all of whom are dual degree students, for their BE Capstone Engineering Design project advancing the development of the Safapani electrocoagulation system for removing arsenic from contaminated drinking water in Nepal. The team created a SolidWorks design of the housing for the system, built a working prototype, wrote assembly instructions, and produced a pictorial user guide so that users not able to speak English would be able to quickly set up, adapt, and use the system to remove contaminants from drinking water. Congratulations on an outstanding piece of work. The Brianna S. Weinstein Engineering Design Prize is presented to a student or team of students who have demonstrated outstanding design skill in developing or creating new technologies, systems, or adaptive devices to address the needs and challenges of people, particularly when appropriate, children or adolescents with physical or developmental disabilities. This year's award goes to the student team of Brian Flint, Catherine Franklin, Blake Osborne, and Kirsten Seegers. For their BE Capstone Design project, they created an inexpensive, easy-to-use device for treating postpartum hemorrhage to address the high rate of maternal mortality in developing nations. In addition, the team created a pictorial instruction manual, provided the potential for FDA 510K approval, and submitted a provisional patent application for filing. The group plans to continue to work with a Tuck first-year project group to develop a business plan, file a utility patent, and gain 510K approval, all with the goal of making this life-saving device available to physicians and communities in the developing world. Congratulations. Every year, the Thayer School faculty and students recognize an individual who has demonstrated excellence in the classroom, teaching across a broad range of courses and projects that embody the Thayer School approach to engineering education. I am pleased to announce that the 2015 Excellence in Teaching Award goes to Dr. Mark Laser, Senior Lecturer and Senior Research Scientist at the Thayer School. Mark? Mark teaches courses in the chemical engineering area on fundamentals of chemical engineering, chemical kinetics and reactor design, chemical process design, energy systems, and energy conversion. With a BS in chemical engineering from Cornell, a Master of Arts in Liberal Studies from Dartmouth, and a PhD from the Thayer School, Mark is clearly broadly educated in the Dartmouth and Thayer tradition and held in extremely high regard by his students. To quote a few, "Professor Laser is always available and happy to answer questions," says one recent graduate. Others, "Professor Laser holds students to the highest standard. He is incredibly knowledgeable and his classes move incredibly fast. He has a true passion for teaching energy conversion. The class was much harder than I expected." Do you sense an emerging theme? "But he made it worth it. Professor Laser was very good about making sure everyone understood the material. He is super approachable, and finally, the ultimate compliment from a student, an overall cool guy." Mark, we're pleased to recognize you for your outstanding teaching contributions. And finally, each year, the Thayer School recognizes a member of the staff for an outstanding contribution to students' education and to the work and community of the school. This year, the 2015 Outstanding Service Award for Staff goes to Mr. Kevin Barron, the manager of the Thayer School Machine Shop. During the 17 years that Kevin has managed Thayer's machine shop, he has taught virtually every Thayer student what he calls the doing side of an engineering education. Overseeing the machine shop's professional staff, numerous student interns, and hundreds of workshop users each year, he stresses the education that students gain from design and fabrication tools. As he points out, every step in the manufacturing progression exposes students to important engineering considerations across a wide range of disciplines. Having learned his own skills in his father's machine shop, at the Harvard Extension School, and finally at MIT's Lab for Manufacturing, Kevin has written that it's a privilege to share his life lessons in advancing Thayer School's mission. I have to add, Kevin is also the most collaborative member in many ways, perhaps on the Dartmouth campus. Wander into the machine shop and you find not only students at all levels, from ABs to PhD students working there, but I have encountered faculty from physics, from the arts and sciences, even recently the head of the studio art department, working collaboratively with Kevin with the machine tools and the facilities of the Thayer School of Engineering staff. It's a true testament to what Dartmouth represents as a broad educational institution. Congratulations, Kevin, and thank you. Each year, The Thayer School recognizes a graduate or friend of Thayer School with the Robert Fletcher Award, which is given in recognition of distinguished achievement in service in the highest tradition of the Thayer School of Engineering. When Robert Fletcher was selected by General Sylvanus Thayer and Dartmouth President Asa Dodge Smith to become Thayer School's first professor and dean in 1870, he was a very young, 23-year-old Army lieutenant serving as an assistant professor of mathematics at the U.S. Military Academy. Over the ensuing 65 years of service to Thayer School and the neighboring community, 47 of those years as dean, Fletcher was to leave a long and lasting impression on generations of students. His accomplishments as director and teacher merged in the minds of his students with his qualities as a human being. So often we refer to Sylvanus Thayer as the father of the Military Academy. As he was the father of the Military Academy, so Robert Fletcher was the father of the Thayer School of Engineering. In addition to leading the Thayer School, Fletcher designed and supervised the construction of bridges across the Connecticut and White Rivers, waterworks for the towns of Hanover and Enfield, and for more than 40 years served as president and engineer of the Hanover Water Company. His many activities on campus and in the community contributed importantly to the development of Dartmouth as an institution and the prestige of Thayer School, the betterment of the local community, and the advancement of engineering education. The individual selected each year to receive Thayer School's Robert Fletcher Award must possess the qualities exemplified in the life and work of this remarkable individual. Today, we are proud to present the 2015 Robert Fletcher Award to Dr. Stephen Chu. Stephen Chu is the William R. Kennan Professor of Physics and Molecular and Cellular Biology at Stanford University. His research spans atomic and polymer physics, biophysics, biology, biomedicine, and batteries. He shared the 1997 Nobel Prize in Physics for the laser cooling and trapping of atoms. From January 2009 until April 2013, Dr. Chu was the 12th U.S. Secretary of Energy and the first practicing scientist, and I believe the first Nobel laureate, in our nation's history to hold a cabinet-level position. During his tenure, he began the Advanced Research and Projects Agency for Energy, known as ARPA-E, Energy Innovation Hubs, and Clean Energy Ministerial Meetings. He was also tasked by President Obama to assist BP in stopping the Deepwater Horizon oil leak in the Gulf of Mexico. Previously, Dr. Chu was director of the Lawrence Berkeley National Laboratory, professor of physics and molecular and cellular biology at UC Berkeley, professor of physics and applied physics at Stanford, and head of the Quantum Electronics Research Department at AT&T Bell Laboratories. Dr. Chu earned an AB degree in mathematics and a BS degree in physics from the University of Rochester, and a PhD in physics from the University of California at Berkeley. He is the recipient of 26 honorary degrees. It will become 27 tomorrow when Dartmouth recognizes him with an honorary degree as part of Dartmouth's commencement. He has published 260 scientific papers and holds 10 patents. In addition to receiving the Nobel Prize, he is a member of the National Academy of Sciences, the American Philosophical Society, the American Academy of Arts and Sciences, the Academia Sinica, and is a foreign member of the Royal Society, the Royal Academy of Engineering, the Chinese Academy of Sciences, and the Korean Academy of Sciences and Technology, all given in recognition of an outstanding career as a scientist, innovator, and leading policy figure. Please join me in welcoming Steve Chu to the podium.
Well, Dean Helbley, that was an overwhelming introduction. I can only fail to disappoint from here on in. But I'm very pleased to be here to address the Thayer School of Engineering, the faculty, the staff, the family and friends, and of course, the graduating students. I should tell you a little bit of why. First, my father was a chemical engineer, a professor of chemical engineering. My grandfather on my mother's side was a civil engineer, professor of civil engineering, so engineering runs deeply in my family. And also, I have to confess, I'm a nerd. In fact, I was so nerdy that I didn't even know you should keep it in the closet. For example, I still have a habit of putting pens in my shirt pocket. My wife hates this habit. She really tries to prevent me from doing this, and now she's making sure I only buy shirts with no pockets. So I felt with President-elect Obama in 2008 choosing me to be the cabinet secretary, the first scientist, I feel like the Jackie Robinson of nerds. But I have to also say that I come from a very distinguished family of academics, and I was the first, I was certainly the black sheep of the family. The older brother and older cousins who went before me of my generation went to Ivy League schools. I applied to Yale and Princeton, got rejected, and went to Rochester, which turned out to be the best thing that ever happened to me. No one heard of my brothers or cousins. Now, my older brother got a PhD in physics, an MD PhD in biochemistry. My younger brother got a PhD and then went on to get a law degree. And so I only had one degree, and so I'm trying to make up for lost time. But I also learned when I was an undergraduate, having lived in the shadow of my family, that you get to college, no one's heard of anybody, and you can take the courses you want and do the things you're interested in. And I followed the advice of Oscar Wilde, which says, be yourself. Everyone else is already taken. Anyway, I thought I could talk about two things. I could talk about energy and climate change, or I can tell you stories about what life was like as Secretary of Energy. So I thought I'd tell you stories about that. First, I never imagined I would be Secretary of Energy. Neither did my mother, but my mother also never imagined I would get a Nobel Prize. The morning after I was told, I called her up. This was 7 a.m. in the morning, and I said, Mom, guess what? I just got a Nobel Prize. There's a short pause. She said, that's nice, but when are you going to see me next? Tiger mom. Anyway, she calls me up a couple of hours later and said, Stephen, it's true. All right, so I loved being a scientist. I loved being a professor and teaching students and also teaching graduate students and postdocs how to do research. And I never imagined myself being an administrator. With all due respect to the wonderful administrators who are willing to serve in that capacity, I was willing to be chair and a couple times, things like that, but always with the eye of doing it temporarily and stepping down. And so I've been asked, why was I willing to become director of Lawrence Berkeley National Lab or take on the role of Secretary of Energy? And it's no secret. The reason I took those jobs and the reason I took the first job was because I, as a citizen, was increasingly concerned about climate change and felt that science, engineering, technology, innovation were going to be the key ingredients to get us to a path of sustainability. And I thought about, I said no twice to throwing my hat in the ring for director of Lawrence Berkeley Lab, but finally I said, well, look, maybe if I go there, I can convince some really outstanding scientists and engineers to get excited about this. It would be worthwhile. I was a graduate student, as pointed out, at Berkeley. I was a postdoc there. But during that time, I was also an employee of Lawrence Berkeley National Lab for 6 years. And this is an extraordinary place. There are about 15 people who've worked there, have gotten Nobel Prizes. But the much more impressive thing about this place is that graduate students, postdocs, beginning scientists, over 30 of them were trained at Lawrence Berkeley National Laboratory. 30 future Nobel laureates. And that's a really high class of people. And I thought, if I can go there and get them interested in energy, clean energy, it would be worth it. And so that's why I went. In November of 2008, I got a phone call asking me to perhaps come to Chicago and talk to the president-elect. I again said, I don't think I'm going to be interested in a federal job. And he said, well, this is important. It's an important job. I said, well, how important? And he said, well, Secretary of Energy. And so I went there and spoke with the president-elect for an hour, one-on-one, in a very warm room. He grew up in Hawaii. and after that discussion, I came back and told my wife, if he asks me, I will say yes. And he asked me, and I said yes. And I went to DC thinking, if I can again bring and attract really outstanding scientists and engineers, it could really help change what we were doing. And during the time I was there, there were 6 members of the National Academy of Sciences or Engineering who were working in the department. 2 of them were elected in their 40s, but were still in their 40s. And so it wasn't as though they were all older people whose careers were behind them. At least 6, in my opinion, will be elected. And so the caliber of people was fantastic. Now, how do you get people like that to, in their 30s or early 40s, take on a government job? And it was a simple, pathetic plea. I said, look, I did this. Just come for 2 or 4 years. Doesn't matter. You have to help us save the world. And a lot of people bought it. So they came, but your job doesn't end there. When you get people of that caliber to come and work in the government, you have to do something else. And so the best thing I did was I blocked and tackled for them. Here's the ball, run with it, and I'll keep the bureaucracy out of your hair. And it was the blocking and tackling and saying that you should use your skills and also help recruit other really outstanding people and bring those people into government. You heard about mention of ARPA-E. It's called Advanced Research Projects for Energy. We started this with the idea that we didn't want to fund incremental work. We wanted to fund things that could be transformational. That means instead of funding singles, we wanted to fund game-changing home runs. But we knew that if you swing for the fences, you're going to strike out more. We fully expected that 90% of the projects would fail. We went into saying this, that we're going to do this. It's all right. But we want to do far-reaching sort of research. And we, in fact, discontinued a couple programs early with consultation with those people and said, no hard feelings. That doesn't forbid you from applying again for something else. We value your attempt, your brave attempt. The people, the program managers in that division were so good that they would, after deciding what to fund, what not to fund, design programs, they would give not only letters saying, congratulations, we're funding you, but to a large fraction of the people who were not funded, we're saying, this is the reason why we're not funding you, but you have 48 hours to respond, and we'll talk to you. That does not happen in a journal, let alone in a funding agency. But they were good enough, they're not going to go back and ask referees for their opinions of the response. They were so on top of it. A founder of 2 companies that we funded, he came and talked to me and said, what is it with these people? They are so good that they're actually helping us solve our technical problems. They met quarterly with the companies or with faculty members, and they're helping us write better business plans. So, when they leave, I want to hire them, which is actually what you want, to have that sort of quality of people. And so these are some of the things that we did. Mentioned Macondo oil spill. That's an interesting story. I'm going to look at my clock. That started, the Department of Energy has no jurisdiction over that oil spill. It was the Interior Department because it was in the Gulf of Mexico. I had made a suggestion to some BP people early on. They kind of laughed at it. It was using gamma rays to figure out what the state of the valves was. And after a couple of days, they said, he may be right. The president heard about it, and then after a cabinet meeting, he went up to me and said, "Chew, go down there and help them stop that oil leak." Yes, sir. And so I thought about how I would do this and decided to call about a half a dozen people, mostly in academia, which would be out-of-the-box thinkers. They were not going to be petroleum engineers. They were going to be crazies who would look for, because this, this oil spill was a serious one, and you're already off the manual. And so the next day I called up these people. They all agreed to drop what they're doing and meet me down in Houston. And I said, oh, by the way, we're having a meeting at 8 a.m. tomorrow. And for the next 3 months, we spent a lot of time in Houston. And when people were not in Houston, it was really literally once or twice a day, emails, 7 days a week, talking about what are the potential solutions. 2 or 3 weeks into this, I began to realize that maybe we could add a little bit more to BP. I think they made a few decisions that didn't turn out to be good. So I finally told Admiral Allen, who is the incident commander, I think from here on in, before they do anything else, we're going to have to, we being me, would say, we're going to discuss this and we're going to have to approve it. Some of the members of my little informal group said, you don't want to do this, Steve. If you do that, you're assuming responsibility for what will happen. And I said, it's okay. Again, no committee, but it's okay because it's really important. It was a co-responsibility between BP and our little committee. And luckily, the president, and I wasn't asking permission from the president, luckily he was backing me very well, and so we decided to do that, and we did help them through a lot of things and through a lot of tough decisions, and I think we helped them avoid some more mistakes. Now, it helps that you can do this if you're not afraid of getting fired. It was one of those secretly I was thinking, make my day, fire me. I can go back in the lab. It also helps, I have to confess, that if you have a Nobel Prize, you might be employable later. Now, this brings me to you, the students. You have the skills that are incredible. And the beginning of what you can do, you have the means, you have the opportunity, you have the motives. So what is it that you will do, what you want to do? I can't give you advice on that. I had a lovely dinner last night and talked to a half a dozen of the faculty members in the School of Engineering and was mightily impressed with what they were doing. But whether it's a new generation of batteries or power electronics or biomedical tools or things that we can't dream of today, you have the opportunity to go out there and make the world a better place and help save the world, because many of your skills will be needed for sustainability and climate change. So I also have to tell you that not everything goes swimmingly in the department. I think in hearings, it's high theater. Senators and congressmen like to try to show that they're tough with members of the cabinet, and so it's a form of theater that you just have to be thick-skinned and not lose your cool. It's not always well with the large bureaucracy. I tried very hard to keep that in check, and as one Department of Energy member said, please, can you stop all the mind-numbing and soul-sucking BS? I was only partially successful. So I'm finishing up now, and I would like to say to you, the students, the things that we did in our philosophy for our PE, and what I tell my students and postdocs is that you should go out there and take risks, and don't be afraid of failing. You know, you're going to fail fast, and move on. And the final thing is, no one prepared me, and no one has prepared you for how fast time will go on as you get older. You probably noticed your 4 years at Dartmouth might have flashed or by very, very quickly, but it's going to get even faster. And when you look back, when you're old and gray like me, and you see what you've done, the choices you've made, think about, you want to be in a position where you say, I like the choices I made. I was willing to take risks, and you were willing to do things that you felt were meaningful and that can really help the world as well as you and your family. And so, to the class of 2015, I'm done. You guys weren't tweeting as much as I thought. I thank you for paying attention, and congratulations.
As part of our investiture ceremony, in recent years, we've begun asking a member of the graduating class to also join us at the podium and share his or her thoughts and brief reflections on time at Thayer. And with that, I'd like to invite James Chin to the podium. James? James came to Thayer School as a dual degree student from Brandeis, where he studied economics and biochemistry. Tomorrow, he will receive his BE with a concentration in biomedical engineering. While at Dartmouth, he created an evaluation system to quantify the performance and learning outcomes of Geisel School of Medicine's Urban Health Scholars Program, which trains medical students to work with medically underserved urban populations. For his capstone project, he developed a breath delivery interface prototype as part of a team of students to demonstrate the feasibility of breath-based medical diagnostics. After commencement and a brief break, James will be moving to Hong Kong. James, welcome to the podium.
Thank you, Dean Helpley. A friend once asked me what I was studying. When I said engineering, he replied, "Engineering? That sounds like a lot of work. Why would you do that to yourself?" It's hardly surprising that Thayer engineers are sometimes misunderstood as pain-seeking masochists. Why else would anyone subject themselves to the tedious problem sets, countless hours spent in lab, and the lack of DBA-eligible food options around Thayer? But we share more than our willingness to endure a grueling workload. What really motivates us is our drive to tackle challenging problems together. Some of my best experiences working in teams have taken place right here at Thayer. The design process taught in Engines 21, Introduction to Engineering, brings together a diverse group of students to address an unmet need. I'll never forget just how excited the custodians were when my team expressed interest in improving the seemingly mundane process of moving cleaning supplies. Shadowing custodians not only gave my team a newfound respect for custodial services, but also helped us discover valuable insights that informed each team member's contribution to our final design. Our commitment to serve each other and those around us is truly what makes the Thayer experience magical. The tradition of collaboration reflects the practice of teamwork, service, and empathy. Thayer's secret sauce is its collaborative culture. However, our tendency to work together doesn't mean that we're incapable of operating independently. Our tendency to collaborate signals that we're intimately aware of when we're at our best and how we can accomplish more together. This deep culture of respect for ourselves and others enriches our ability to understand complex problems and overcome daunting challenges. As we begin the next phase of our lives, I hope you will not only remember the all-nighters in McLean 210, that impossible black box lab, or the free food outside of Jackson. I hope you will also remember the very special group of people who have helped you along this journey. Lastly, I urge you to share your gifts, your ideas, and your energy with those you encounter in the future. We need to be leaders who exemplify a culture of collaboration. Congratulations on this momentous achievement. You will make phenomenal Thayer ambassadors. I can't wait to learn about the amazing things you will accomplish in the coming years. Thank you.
Thank you, James. We will now begin conferring of hoods on degree candidates. Professor Ian Baker will read your names, and please proceed to the podium accordingly.
For the degree of Bachelor of Engineering, Megan Patricia Dagler. Emily Callahan-Bear. Arthur William Bledsoe. Jonathan Carter Brink-Roby. Alison R. Brockman. Matthew Dowd Burton. Sekar Bayahut. Tom Yiping Chang. James N.Y. Chin. Rachel Elizabeth Decker-Sadowski. Brian Dopkins Doolittle. Ethan Dreisigacker. Walker Dula. Brian Rohrbach Flint. Catherine Jern Franklin. Sarah Catherine Hammer. Scott Travers Hansen. Eric Warren Hemphill. Paul Henderson Hogan. Byungwook Jang. Stephen Norcross Jenkins. William Kimpton Jewett. Hilary Anna Johnson. James Hunter Capel. Malia Laurel Kawamura. Matthew Cooper Keller. Nathaniel Jacob Lewin. Feynman Sang Yang Liang. Pratap Luitel. Caitlin Elizabeth Mayer. Daniel Sahul Martinez. Jacob Daniel McIntyre. Ellen C. Mayer. Daniel Chiamo Miller. Eric Arthur Miller, Jr. Stephen Charles Munson. Brendan Francis Nagel. Harti Nagayan. Julia Rendon Ocampo. Caroline Grace O'Donnell. Shane Ridgway Ogren. Blake M. Osborne. Teresa Yi O. Karina C. Packer. Lauren Paley. Benjamin Palmer. Claudia Lynn Pham. Jamie Tutera Potter. Anne Elizabeth Resler. Nicholas Joseph Resnicek. Brian Rogers. Alex Robert Rowe. Kirsten Ann Seegers. Timothy Joseph Serkis. Eric A. Scarin. Nicole Dagmai Lam Sonnert. Ariana Moselle Sofa. John Victor Stanley. Yar-Chen Soon. Alexandra Page Tykowski. Lydia Judith Valdez. Laura Vang. Thomas Sean Wilson. Jeffrey Austin Yates. Julia Hopkins Zakorski. For the degree of Master of Engineering Management, Drew Michael Paul Murta. Nishant Agarwal. Charles Robert Bowman. Emir Kukut Berika. Nadia Mahmood Bhatti. Mark Lewis Biondi. Sheetij Chilimbi. James John Christie. Brennan Alexander Costello. Gabrielle Marie de Garma. Elizabeth Mary Donovan. John Robert Forestier. Darshil Vimal Gandhi. Matthew David Gibbons. Fong Han. Santiago Oriche Costa. Hua He. Arpita Johari. Shaina Kurana. Heather Lynn Klug. Amit Ramakrishna Kaushik. Yun Kyu. Adi Shubomi Laditan. Varun Malampalli. Federico Mazzoli. Hector Antonio Marino. Parag Patil. Chad Jacob Piersmar. Sandra Viviana Rosias. Kyle Pert Saltzman. Parumviam Saxena. Ashna Sharma. Haifen Shen. Adita Srivansan. Kalika Shrivatov. Wendong Tang. Chika Ann Ugbo. Shui Wong. Richard Jarrett Wester. Sean Schwan. Irene Zhang. Yihan Zong. For the degree of Master of Science, Mitchell Fung. Elliot James Kastner. Udite Meshra. Rui Tian. Yinlin Wang. For the degree of Doctor of Philosophy, Adam Kenneth Glazer. Regina Sophia Solvart. Scott Snyder. Chengwei Su. Tanvir Talukdar. Xuan Wang. Sane C.
Please join me in a round of applause for all of our graduates. Thank you. A few brief announcements before we adjourn. First, to families and friends, a professional class photograph will be taken immediately after the ceremony in Moore Theater. Graduates and faculty, please recess to Moore Theater via the scenery shop. The order for pictures will be first the entire group, and then a photo of the MEM class, and then we will pause for some photos with the Fletcher Award recipient. Thayer School will post downloadable class photos online on Flickr as soon as possible after the ceremony. That means soon, not immediately. Please give us a few days to get the photos posted. You'll find the URL for the Thayer Flickr site on the bottom of your Investiture program. I would also like to invite, but for the moment I'll invite all of you, graduates, family, friends, faculty, staff, and distinguished platform group, to a reception in honor of our graduating students in the tent that's immediately at the front of the Thayer School. The reception will begin as soon as the photos are concluded. It's a very nice lunch reception. I hope you'll all be able to join us. There will be 2 shuttle vans returning to Thayer School, one that will pick up at the Lebanon Street exit. So when you exit the auditorium, go down the stairs to my left and head south to the glass doors. The other will be at the main entrance to the Hopkins Center next to Moore Theater, which is where we'll be taking pictures. For commencement tomorrow, the faculty will meet at the Hopkins Center and students will meet in front of Wentworth Hall, both no later than 9 a.m. This is your final Dartmouth 9 a.m. call. AB and BE students should report to Lead Arena no later than 8:45 a.m. Much of my job and most of my days find me working with our faculty and staff in the Thayer community to look ahead. Where are enrollments increasing? How is our research funding looking? Should we build a new building? Should we convince computer science to move across campus and move in with us? The answers to these questions, by the way, are enrollments are increasing everywhere. 2015 will be an all-time record year for new research grant dollars at the Thayer School, all-time in our history. Do we need a new building? Oh, yes. And computer science? Emphatically, yes. So I would encourage all of you to come back in 4 or 5 years and you may see some exciting things in store at the Thayer School. But there are also moments in my day-to-day where it helps to look back. Sometimes this is something that happens by design. Sometimes it's something that just happens. Like earlier this week when I was walking across campus along Tuck Drive, and I found myself glancing over at the cemetery and wondering if Bobby Fletcher could have ever imagined what this school that he helped create would become. We all credit Sylvanus Thayer for his vision in founding the Thayer School and for understanding, even in the 19th century, at the dawn of the industrial age, the importance of giving engineers a scientific and a liberal arts foundation for their education. But it was actually Fletcher who built the foundation, brought in the admissions requirements, and insisted on avoiding early specialization, which was a radical idea in engineering education in the 1870s. As you all know, this radical idea remains so very true today. It's an educational philosophy that's highly unusual. It's an approach that is not the norm, and it is one that you, our graduating students, have not only embraced, but fully come to embody through your time with us. And through this, You remind us all that engineering is about applying knowledge, about applying your knowledge to improve the human condition, to use technology for the betterment of humankind. As I said often from this stage, our board chair seated behind me, Mr. Terry McGuire, reminds us often to think of lives touched as a measure of the impact of our work. Well, I'd like to finish by asking all of you to reflect back on your time here and think about the impact of your work and through it of the countless lives that you have touched. Examples abound from every one of your classes and degree programs. Through Dartmouth Humanitarian Engineering, DHE, you traveled to Rwanda and Tanzania to help communities, impoverished communities, find engineering solutions to address local problems, resulting in a small hydropower system used to charge batteries and a renewable, environmentally friendly cooking fuel. As student leaders in the first LEGO League robotics program and in the after-school science and engineering program, you got engaged in the local community. Even in your busy student lives, you found time to do this and encourage young people in New Hampshire and Vermont to get excited about STEM. I cannot emphasize enough the importance of that work in getting the next generation of science and engineering students excited about the possibilities of the world that you will be going off to inhabit. You created a semi-prone bicycle, as we heard earlier today, to optimize the biomechanics of cycling. You designed and fabricated a test rig to evaluate a new means of boat propulsion. You developed a low-cost device to improve health outcomes for mothers in Nepal. As MEM students, you analyzed emerging technologies from a holistic engineering perspective, exploring the feasibility of using microgrids to deliver electrical power in India or precision agriculture to farm coffee beans in Latin America and Africa, meeting the needs of people in these developing nations. You explored the use of bioprinting for human tissue and organ regeneration and looked at flexible electronics on implanted medical devices as a tool for improving human health. You published your work in major scientific journals. You presented your research and represented Dartmouth engineering at national and international conferences. 19 of you, 19, have either filed or are about to file for intellectual property protection for these and other inventions that have been developed during your time at Thayer School. 6 of you, spanning the range of our degree programs, have already, as students, co-founded 4 companies. You even shared your ideas for that new building I mentioned a minute ago over Friday beers, giving your input on the student perspective, and something about food kept coming up over and over again in those conversations. And I also know from firsthand observation that through all of this and the intensity of your work and efforts, that you managed somehow to have fun outside of engineering. From challenges like the die wheel races on the green, to a tug-of-war last month with the Thayer Board of Overseers, who I still maintain were at a competitive disadvantage because of their foolish insistence on wearing kilts for the competition. You remind us all that even in an intense engineering environment, it's important to step outside and have a little fun. This is all part of what we value about you, and it is all part of what we have learned from you. At Dartmouth, and especially here at Thayer, it's not just the depth of your technical knowledge and skill, but it's the breadth of your vision, the range of your insight, and your ability to connect that technology, the technology that's the focus of your work, to the lives of the people it will benefit. With engineering as the core part of this broad educational foundation you've built, you now have the tools not only to touch lives, as our board chair likes to say, but to change them, to truly go out and change the world. And I, for one, am absolutely certain that you will. To you, our students who've left your mark on us, your faculty and staff, colleagues and friends, I say thank you. And to your family and friends who are gathered here with us in this auditorium today, I would like to again say thank you for lending us, your sons and daughters, your family and friends, this extraordinary group of talented individuals. On behalf of the entire Thayer community, it's been a privilege to get to know you and to work with you these past many years. Congratulations. This concludes our investiture ceremony.